So what we're going to be doing today is you're going to be able to walk out the door and be able to graph cosine. Last time you were able to graph sine. And if you can graph sine, you can graph cosine. It's the same idea. So now keep in mind, when we're graphing cosine, what we're doing is instead of having it on the unit circle, we're just plotting it out on a XY chart here. So we're going to map out cosine. Now remember that cosine is our X values on the unit circle. So and remember, we could plot as many points. We could literally plot every single one of those points, but that's a lot of points to plot. So that's why we choose those special 5 points. The 5 points that we use just to make our life easier. We graph pretty points. So remember, we graph 0, pi halves, pi, 3 pi halves, and then 2 pi, right, everybody? The 5 points. So here we go. At 0, cosine is at 1. Does everybody see that? So at 0, cosine's up at 1. So let's plot that. At 0, we're up at 1 for cosine. And then at pi halves, so take your eyes to pi halves, our cosine function's down to 0. So now we're over pi halves, down, or up 0. Take your eyes to pi. Our cosine then drops down to -1. So over pi, down -1. Then take your eyes down to 3 pi halves. Our cosine is then back up to 0. So now we come back up to 0. And then back to 2 pi puts us back up at, look, 2 pi. This is 2 pi. We're back up at 1. So that was one cycle for cosine. So, budink. Now notice, it kind of looks, remember how last time the sine, I said, if you tilt your head, squint your one eye, and close your other eye, our one cycle, our one period for sine looks like 0, max, 0, min, 0. It looks like a sideways S, correct? Now if you tilt your head, squint your eye, and close the other eye, do you see how this looks like a sideways C? Do you see how it looks like a sideways C? So that's when I always say to myself, okay, cosine, I go max, 0, min, 0, max. So cosine start at max, 0, min, 0, max, making our sideways C. That makes kind of sense, everybody? Okay, so our 5 points are going to follow that pattern for cosine. We start at the top, 0, min, 0, max. All right, so now we could continue to go around the unit circle as many times as we want, which would repeat a pattern. So we're going to do that same pattern. So right here, we're going to be at the top, then 0, then min, then 0, then max. And there's our second cycle for cosine. And remember that this really continues, so we draw our arrows. So I'm not going to fill in these points because the periodic function repeats patterns, so we could fill it in, but we don't need to. Everybody good? No questions? Okay, so what's our domain for cosine? Isn't it growing this way forever and that way forever? We can sit and go around the unit circles as many times as we want. So our domain is -infinity to +infinity, or we could say all real numbers. And our range for cosine, our lowest value is -1, and our highest value is 1. So isn't our range bouncing between -1 and 1, everyone? And we're good there. So add that in there. So pretty simple. Okay, go ahead and flip over. Well, maybe just write this at the top. So this is the equation. It's not anywhere there for you to write. So find a place to write this. The equation for cosine is y is equal to a cosine of b times theta, where a is our amplitude, just like with sine, and b is the number of cycles from 0 to 2 pi, just like sine. So this is exactly the same idea here. And even the period is the same for cosine as it is for sine. So our period will be 2 pi divided by b. And b is the number of cycles from 0 to 2 pi. Period is the length of one cycle. So the period is going to be this, 5 points. Max, 0, min, 0, max. That would be the physical length from there to there would be our period. That's what period means. So cosine is the same as sine. So now it's pretty easy just to extend our knowledge from what we learned last time, because it's the same idea. Are we ready? Good to move on or need more time? Okay, here we go. So look at your example A with me. It says, what are the domain, period, range, and the amplitude of the cosine function? What are the max and min values, and then where do the zeros occur? So it says, what's the domain? So let's look at this. What's the domain? Well, obviously, what's it growing from left to right for cosine? All real numbers. Isn't that the domain, everyone? Okay, it says the period. It's kind of jumping all over the place. Let's just do range while we're at it. For this function, isn't our amplitude +2 and -2? So isn't our range -2 to +2? The lowest point's -2, highest point is +2. Let's find our period, which means physical length of one cycle for cosine. Now remember, cosine starts at the top. So everybody look. 1, so max, 0, min, 0, max. There's the length of one cycle. Where did it end? Pi. Very good. So our period is pi, everyone. Very good. And then the amplitude, we said, was 2. Remember, amplitude's always positive, so our amplitude is 2. And where do the max and min values occur? Where do the zeros occur? So let's highlight. Now, there's going to be lots of these, but we're going to talk on an interval. We're just going to look from what we can see from our graph, what are our max values. So isn't that a max value from my graph? So you literally just say, like, you'll state, my max happens at this xy point and this xy point. So that's over 0 up 2. Another max happened at over pi up 2. Questions on that? Yes. Yes. Just from what we can see, it didn't say in the instructions, so we're just going to go off of what we can see on our graph. Does that make sense? Okay, let's do our mins. From what we can see on our graph, that's a min, and that's a min. So our mins happen at the xy points of -pi12 down 2. Another min happens at over pi12 down 2. And our other one happens at 3 pi12 down 2. Now it's asking us, where are the zeros? So let's highlight. Zeros are across of the x-axis. Across there, 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 and there. So we have many zeros. So this is going to take a lot of listing. So zeros. So that happens at -pi4 sub 0. -pi4 0 over pi4 0. Over 3 pi4 0 over 5 pi4 0 and 7 pi4 0. Just where zeros are where it crosses the x-axis. We know that that's what zeros mean for all functions. And then looks like we've answered everything. We could write the equation for cosine, but it doesn't ask us to, so we won't, I guess. Okay, let's do the next one. So it says, once again, same thing. So our domain is obviously all real numbers for cosine. We can go around the unit circle as many times as we want. Our range, to me, that's kind of hard because it's not quite down to -1, is it? It's like 3/4 of the way up, roughly. So we'll do our best here. It's going to be very straightforward on a test, like it's going to be a whole number. So our range is bouncing between -3/4 and +3/4, I would say. Once again, our period is the length of one cycle. Remember, that's what period means. So max for cosine, that's making a C. So max 0, min 0, max. So our period was pi again, wasn't it? The length of one cycle. Okay. And then our amplitude is 3/4. And then we could go through and find all the max values and min values, but I'm not going to list those out again. Do we all understand them at least? Then why beat a dead horse? Okay, moving on. Here we go. So write the equation for each cosine curve. This is more like it. This is more like it. So here we go. We say to ourselves, we know that cosine has this form. Y is equal to A cosine of B theta. You've got to remember what each of those things mean. Amplitude, and then that's the number of cycles from 0 to 2 pi. Here we go. So for this one, our amplitude is up a half, isn't it? So we'd say y is equal to 1/2 cosine Now, let's see. We can see 2 pi, so let's count. Since that's the easiest way, if you can see 2 pi. So we would start out for cosine. Our 1 period is max, 0, min, 0, max. And didn't that end at 2 pi? So our period, the length of one cycle is 2 pi, and the number of cycles from 0 to 2 pi is just 1. So we would have 1 theta, or we'll just write theta. Since there's only one cycle from 0 to 2 pi, it's just a 1. Okay, next one. We would do, okay, so we're writing an equation here. Now notice at this axis, are we starting at the bottom? So doesn't that mean that these must have had a negative in front where A is? Because that reflects our points, doesn't it? So instead of our points being max, 0, min, 0, max, if I have a negative in front, that's going to be min, 0, max, 0, min. Does that make sense? That would reflect them? So looking at this one, notice we start at the bottom. Min, 0, max, 0, min. There's a period right there. Okay, so anyways, keep that in mind. So we're going to have y is equal to, it looks like our amplitude's 2, but we need to put a negative since it started at the bottom. Negative 2. Is anybody confused on that? Do I need to go into more detail? Now let's count how many cycles. I just did 1, so then min, 0, max, 0, min. There's our second one from 0 to 2 pi, 0. Sorry, min, 0, max, 0, min. And how many colors do we see? 3. So it'll be negative 2 cosine of 3 theta, because there was 3 cycles from 0 to 2 pi. All good? Okay, almost done with the examples, and the rest of the time will be yours. Okay, let's answer that. We're writing the equation for cosine here. So my amplitude's 1, so we're going to have y is equal to 1, so just cosine, and now we have to figure out what b is. B is the number of cycles from 0 to 2 pi. Now look, if we try to figure that out, do you see how that's cutting us off like in the middle of, we can't really tell exactly, right? So shouldn't we actually use our period, because we can figure out the length of one full cycle. So let's think about that. So the length of one full cycle for cosine is max, 0, min, 0, where it's not extended. We might need to extend this out a little bit. Trying to draw it a little bit to scale. Okay, so if this is 7 pi, look. Okay, we've got to finish filling out our x-axis here. Here's 1 pi halves, 2 pi halves, 3 pi halves, right? 4 pi halves, 5 pi halves, 6 pi halves, right? 7 pi halves, 8 pi halves, which is 4 pi. Do you guys see it? 9 pi halves then this will be. So let's fill it in, 9 pi halves. Then this will be 10 pi halves, which is 5 pi. So our next point looks like it's hitting here, right? It's hitting here at our 0. And then our next one will be at our max, which was 1, right there. So then I didn't draw it very good. So the length of one cycle was 5 pi. Wasn't that our period, everybody? So our period is 5 pi. So now you'll have to say to yourself, that's not b though. Remember that period equals 2 pi divided by b. So since we know this is 5 pi, let's put in our 5 pi here. So 5 pi equals 2 pi divided by b. Now let's solve for b. Yes. Yeah, it would be now that you say that. Because look, it's skipping 2, isn't it? Do you see how between each 0 it's skipping 2 units? Like, do you see what I'm saying? I just did the next unit, didn't I? Felt squished. I knew it felt squished. So we shouldn't have been at 5 pi quite yet. It passes 5 pi. Let's see, where does it end? So 9 pi halves, 10 pi halves, which was 5 pi. Oh, wait a minute. 11 pi halves. Then won't it end at 11 pi halves actually? Or am I not thinking right about that? Let's think. Let's see. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2. It'll end at the third. Yeah, we need to go. Good point. I'm glad you pointed that out. So it's actually going to end clear up here. Totally messed that up. Okay, there we go. Good fix. Good fix back there. Okay, so this actually is 6 pi right here. 6 pi. So this is actually 6 pi. So now let's solve for b. So we multiply both sides by b. That one took some thought, so I like it because it made us think a little bit. So we have b times 6 pi equals 2 pi. Solve for b. Divide by 6 pi. Divide by 6 pi. So b is equal to 1/3. Which, if you look at it, it makes a little bit of sense. So b is 1/3, so our answer is y is equal to cosine of 1/3 theta, which we know we've been seeing it like this. Y is equal to cosine of theta over 3. Same thing, right? So we've been seeing it as. Now, if you think about it, look at our picture. Do you see how from here to 2 pi is about 1/3 of the way, everybody? From 1/3 of our cycle. Do you see what I'm saying? So that makes sense. Okay, awesome. Good catches once again. Okay, let's do this one. So it says write an equation. So we're given our amplitude is pi. So we'll write y is equal to pi cosine. Our period's 2. Now I didn't give you the number of cycles, which is b. So we've got to go through and use algebra again to solve, right? Since our period equals 2 pi over b, we're given our period is 2. Put that in here. So 2 is equal to 2 pi over b. Solve for b. Times by b. Divide by 2. So what's my b? Pi. So we have pi cosine of pi theta. Now it says assume that a is greater than 0. That means this is positive. Does that make sense? So it's not reflected, yes. Uh-huh. Yes, same thing. Yeah, they're equal. No, you're fine. Yep, we could write it either way, both correct. All right, let's do this one. Our amplitude is 1.4. Okay, so y is equal to 1.4 cosine of b theta. We know b means number of cycles, not the period, so let's do our algebra again. Since our period is pi fourths, we'll put it in there. So pi fourths equals 2 pi divided by b. Solve for b now. Multiply by b. The b's divide out. So we would then multiply by 4. The 4's divide out. So we have b pi equals 8 pi. Divide by pi. Divide by pi. So b equals 8. So we would know it'd be 1.4 cosine of 8 theta. Yeah, do some algebra for those. Okay, we're down to the last couple examples here. Here we go. The rest of the time will be yours. You'll be able to finish in class today. I know it. It says graph the cosine function. So grab a white piece of paper. You are doing it from scratch, and you are graphing 2 cycles for cosine. I'm telling you, that's what I'm asking you to graph, even if your instructions tell you something different. So the first thing we do is draw in our x, y. Draw it in. Give yourself some good room, people. No, this is actually off of your green worksheet. If you flip to the back, but we're going to do it all from scratch. Once again, because it really does make your life easier a lot of times, even though it might not feel like it. Okay. So now what we're going to do is figure out our amplitude from the equation, which is 1.5, correct? I'm sorry, no, it's off the green worksheet. Did I say blue? Green. Okay, just making sure. Green, it is off the green. These are your examples. Now our period, we've got to calculate. That's 2 pi divided by b, which b is 2. So 2 pi divided by 2, which is pi. So the length of one cycle is pi in length. Everybody good? Okay, here we go. So now we're going to go up. Let's go like this. So I don't really care that much on how accurate, like if you're drawing it yourself, like for example, we'll call this 1.5. Everybody good? This is negative 1.5. So then we're going over 1, 2, 3, 4 tick marks, and that's going to put me at pi. Because that would be my 5 points. 0, da, 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 da. Everybody good? Then we're going over, since I'm having you draw 2 cycles, we're going to draw in another 4 tick marks. 1, 2, 3, 4. Pi in length plus another pi in length will put me at 2 pi. Now it's a requirement for you to fill in every x point on the x-axis here. So what's the halfway distance between 0 and pi? Cut 0 and pi in half and we get pi halves. So right here is pi halves, everybody. Now let's keep going. What's between 2 pi and 1 pi? Well, let's add them up. What's 1 plus 2, everyone? 3. 3 divided by 2 is 3 halves. So right here is 3 pi halves. That's the halfway distance. Let's fill in the rest. 0 and pi halves, what's halfway between? Pi fourths, correct? Now with this one, it happens to be pretty easy. This is 1 pi fourths. This is 2 pi fourths in distance. Won't that then be 3 pi fourths? Let's see if we can do it the other way. What's 1 plus 1? No, wait. What's 1 half? Sorry, my fault. What's 1 half plus 1? 3 halves. Divided by 2 would be 3 fourths. So do you see how this is 3 pi fourths, everybody? I'm going to do it this way. 4 pi fourths, this is 5 pi fourths then in length. Look, 6 pi fourths, which simplifies to be 3 pi halves. This must be 7 pi fourths. Now check to make sure you end up at the right spot. 8 pi fourths. Yep, that's 2 pi. Now we've done the hard part. Now the cosine part, drawing in the cycles is easy. Remember, for cosine, our 5 points start at they make a C. Max, 0, min, 0, max. So here we go. Max, next point, 0, next point, min, next point, 0, next point, max. And we can draw in that one cycle, that first cycle, and we're good. We've made our C. Let's draw in another cycle. So max, 0, min, our pattern's repeating, 0, and then we should end up at the max. And now we can draw in our second cycle for cosine, drawing in our arrows saying that it continues. And that's it. All good? Okay, let's do this one. Quickly, let's graph this one, and then if you guys feel confident, I'm just going to stop there. I won't do more examples if you feel super confident. Okay, here we go. Graph the cosine function. So we'll draw in our x, y once again. Our amplitude is technically 1. Our amplitude is 1. The negative will affect our graph, but that just means instead of max, 0, min, 0, max, that we'll be doing min, 0, max, 0, min. We'll get to that in a minute. So that's what that negative does. Our period is 2 pi divided by b. Well, our b is 1 half. So 2 pi divided by 1 half is 4 pi. The length of one cycle will be at 4 pi. So we're going to go up 1, down 1. Then we're going out 1, 2, 3, 4. That will put me at 4 pi in length. Going out 1, 2, 3, 4 will put me at 8 pi. 4 pi plus 4 pi is 8 pi. Now cut 4 pi in half, we get 2 pi. 4 plus 8 is 12. Divided by 2 is 6. That puts me at 6 pi there. Then this is 1 pi. Then look, it counts. 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, and 7 pi, 8 pi. So we've done the hard part. And now cosine, since it was negative, we'll start at the min. 0, max, 0, min. And make sure you ended up at the right spot. The length of one cycle was 4 pi. That's where we ended. Bouncing back up. Now min, 0, max, 0, and then min. We ended up at 8 pi after another cycle, so we're doing good. And we're done. Everyone feeling good about this? Pretty easy when you've learned sine. Okay, finish the worksheet. The rest of the time is yours. So I get that in the next 25 minutes, you'll be able to get a lot of that done, if not all of it.